In this class, we're going to learn how to find the derivative of a logarithmic function. To understand how to find the derivative of a logarithmic function, let's start by learning how to expand. You understand? Okay, from the basic rule of logarithm, please kindly pay attention. From the basic rule of logarithm, we have the natural log of the product of a and b. It can be written as the natural log of a plus the natural log of b. You understand? That is, the product of a log is equals to the sum of the log. Okay? Now, these rules are important. These rules that I'm about to give you, they are important as far as logarithmic differentiation is concerned. Okay? Now, let's talk about the quotient of a log. This one is the product of a log rule. This one that you have here is the quotient of a log. What's the meaning of quotient? Quotient simply means division. Okay? So here we have the natural log of quotient of a and b can be written as the natural log of a minus the natural log of b. Okay? Please kindly pay attention. Now, let's say we have the natural log of a to the power of b. This can be written as b multiplied by the natural log of a. You understand? You see, all these three rules are very important. Okay? All these three rules are very important. It's just like when you are dealing with logarithm, you understand, from your basic mathematics, when you are dealing with logarithm, the log of a product, please pay attention. This one is natural log, you understand? This is log. Okay? The log of a product is equals to the sum of the log. Okay? Log A plus log B. Okay? Now, if you have the log of a quotient is equals to the difference of the log. Log A minus log B. Okay? And eventually, if you have something like this, log A to the power of B is always the same thing as what? B log A. Okay? Now, see, it is still the same. Okay? It's just like changing this log to natural log. You understand? This link that you see here means natural log. Okay? Now, having learned the basic rules, this is enough as far as logarithmic differentiation is concerned. Okay? Now, let's look at some basic example before we delve into more complex one. Let's say you are asked to find the derivative of, please pay attention. Let's say, okay, question one. Let's say you are asked to find the derivative of ln x. Ln x. You are asked to find the derivative of ln x. How do you differentiate ln x? In differentiating ln x, check the function inside the bracket. The function inside the bracket is x. Now, all you have to do is that just let y equals to ln x. Okay? Now, we are differentiating y with respect to x now because you see, you can use any letter. Okay? Don't be confused. I just say let y equals to ln x. Okay? You can use any letter. Just know that you are differentiating that letter with respect to x. Okay? Because we have been given the x in the question. Okay? Now, in differentiating in x, that is what? 1 over x. How do we arrive at 1 over x? Anytime you are asked to differentiate a function that has a natural log, please pay attention. For example, this, I want to show you how to get 1 over x now. All you have to do is that just take the inverse of the function inside the bracket. The function inside the bracket is what? Is x. So I take the inverse of x, then I will multiply it by the derivative of the function inside the bracket. So I'm going to take the derivative of x. And you know that the derivative of x is 1. So I'm going to have 1 over x multiplied by 1. Hence, the derivative of y is 1 over x. Do you understand? So eventually, you often see in textbook that derivative of ln x is 1 over x. That's how they got it, okay? Now, let's say we have another function, y. Let's say we are asked to differentiate ln x squared. How do we find the derivative of this function? You see, all you have to do is just to pay attention. All these are simple, okay? So that by the time we delve into a complex example, you are going to understand, okay? See, all you have to do here is that just take the inverse of the function inside the bracket. You can see that x squared is the function inside the bracket. So I'm going to have, let's say y equals to ln x squared, okay? So the derivative of y with respect to x is equals to 1 over the function inside the bracket. The function inside the bracket is x squared. So I'm going to have 1 over x squared multiplied by the derivative of x squared. This sign that you see here means derivative, okay? The sign that you see here is not raised to the power of 1. That means that I'm I'm telling the examiner that I want to differentiate x squared. Okay, so I'm going to have the derivative of y is equals to 1 over x squared multiplied by, if you differentiate x squared using the power rule or the polynomial rule, you are going to have 2x. So I'm going to have multiplied by 2x. Hence, I'm going to have the derivative of y is equals to, okay, let us rule a line. Let's rule a line here. The derivative of y is equals to 2x all over x squared. Okay, so you can rewrite it as this. Derivative of y is equals to 2x is what? You know, 2x is equals to 2 times x, and x squared is equals to what? X times x. So this x can cancel this x, so I'm left with what? 2 over x. So the derivative of y is what? 2 over x. Okay, now I want to do this one. Question 3. Let's say you are asked to find the derivative of ln 2x squared plus 1 raised to the power of 2. Okay, let's take it step by step. Let's say you are asked to find the derivative of this. How do you take the derivative? You just proceed like the same step. First, take the inverse of the function inside the bracket, then multiply it by the derivative. Okay, so let's say let y equals to ln 2x squared plus 1. So let's take the derivative of y is equals to, take the inverse of the function. Inverse simply means the reciprocal. Okay, so here I'm going to have 1 over 2x squared plus 1 multiplied by the derivative of 2x squared plus 1. Okay, so derivative of y is equals to, with respect to x, I'm going to have 1 over 2x squared plus 1 multiplied by, okay, differentiate 2x squared plus 1. You're going to have 4x plus 1. So I'm going to have 4x. Oh, sorry. Differentiate 2x squared plus 1. You're going to have 4x. Because if you differentiate a constant, you're going to have 0. Okay. But 1 is also a constant. So if you differentiate 1, you're going to have 0. Okay. So here I'm going to have 4x. So the derivative of y is equals to 4x all over 2x squared plus 1. Okay. Now, all these that I gave you, they are just the basic knowledge. Okay. So let's say you are asked to differentiate, okay, number 4, you are asked to differentiate ln x squared minus 2x raised to the power of 4. How do you find the derivative? How do you find the derivative of this function? What do? You can see that this is a bit different from what we did earlier. We have 2x squared plus 1 raised to the power of 1. This one is raised to the power of 1, so we can easily differentiate this. Now, how do we find the derivative of ln x squared minus 2x raised to the power of 4? Don't forget, the reason why I wrote some rules here is because I want to understand. Now, if you look at this function, that we have to differentiate. Which rule does it look like? You can see that it looks like this. It looks like ln a raised to the power of b. You understand? That is, where a is the function inside the bracket, that is x squared minus 2x, and b is the power. The log of a power is the product of that power and the log. You understand? That is the rule. The log of a power is the product of that power and the log. Now look, see, we are having the natural log of x squared minus 2x to the power of 4. According to this rule, the log of a power, ln a raised to the power of b, is equals to b multiplied by ln a. You understand? Now, that means I can rewrite that question 4. I can rewrite it as this. Let y equals to ln x squared minus 2x raised to the power of 4. I can rewrite it as this. 4 ln x squared minus 2x. You understand? That is, this power will multiply this. You understand? Just like the basic rules that I wrote here. The log of a power is the product of that power and the log. Okay? So now, we can easily differentiate ln x squared minus 2x now. Let's proceed. The derivative of y is equals to 4 multiplied by, okay, now I told you that if you are asked to differentiate a function, all you have to do is that just take the inverse of the function inside the bracket. The function inside the bracket is x squared minus 2x. So I'm going to have 1 over x squared minus 2x, oh sorry, 1 over x squared minus 2x multiplied by, okay, now differentiate x squared minus 2x, that is 2x minus 2, okay? So I'm going to have 2x minus 2. So the derivative of y is equal to 4 multiplied by 2x minus 2 all over x squared minus 2x. Okay? Now, the derivative of y is equal to, you can open the bracket if you like. 4 times 2x is what? 4 times 2x will give us 8x. And 4 times negative 2 will give us negative 8. So I'm going to have negative 8 all over x squared minus 2x. Okay? So the derivative of this function is 8x minus 8 all over x squared minus 2x. You understand? Okay? So I'm very sure you understood the basic derivative, how to differentiate a logarithmic function. This is just the basics, you understand? Okay? And understanding this basic will ease you of the problem and of the difficulties that you might encounter as we progresses. You understand? Because by the time we give you complex function, if you don't understand this, you might not be able to solve those questions. Okay? So you can attempt this, okay? Attempt this question. I want to attempt this, question 5. Find the derivative of y equals to ln x squared plus 4x raised to the power of 5, okay? So attempt this question.